So I'm going to talk through some kind of pod patterns that we have kind of put together while we're working on some projects. I think kind of pragmatic is kind of an important word here, because some of the things we've done when we've come across particular problems aren't necessarily they're not necessarily the quickest, they're not necessarily the neatest, some of them look a bit interesting at times, but they're the kind of things that are kind of sensible, a kind of common sense approach to help us kind of get things done quickly. Okay, I'm from Capgemini's Digital Platform Engineering Unit. We're kind of a UK kind of DevOps resource for Capgemini, and we've got a significant presence within the public sector. We're always on the lookout for skilled platform engineers as well, so there's a few of us kicking about if you want to chat. So this are a few points from the government's kind of digital transformation strategy, 2017 to 2020. So this is the kind of thing that the government's looking for. This is what they're trying to do kind of in digital. So we've got things here that basically in the end break down into improve user experience, kind of improve delivery speed, cost and time to build, and then things like data security and actual system security itself. So a bit wordy, but it's kind of very similar to kind of most projects that are out there, the kind of goals they're aiming for. Public sector does tend to have a kind of an extra goal in general, which is, don't become a headline. So that's the kind of Daily Mail factor that we kind of try and avoid. But in general, it's kind of like similar to other large projects. What can be a little bit different is the makeup of the team. So they're often quite large projects, but they're also rainbow teams as well. So the government as kind of policy will often have kind of multiple consultancies on particular projects. So each team may be made up of a number of civil servants, consultancies, and contractors. And with that, you get kind of like a wide range of experience, you get a wide range of skill sets. We've also got a wide set of tools as well. So on the kind of projects I've worked on recently, these are kind of like the core tools kind of we've worked with. So Kubernetes is obviously a big one, kind of quite heavily into Amazon Web Services. Things like the HashiCorp stack, so kind of Vault and Terraform, but also things like Packer as well. And obviously what this means, with the kind of size of the teams that we've got and the amount of tools that we use, we've kind of got to be really careful about overcomplicating what's already kind of quite a complicated setup. We don't want to reinvent the wheel all the time. We don't want to add more tools unless there's a clear advantage as well, because we've got a lot of engineers from different places, we've got a lot of tools. And we want to make it easy for new teams to come onto projects, to kind of get started quickly and not have to kind of reinvent something that someone did kind of a year ago on a different part of the project. So we tend to kind of take this kind of pragmatic platform engineering approach here. So, I mean, if you look at projects these days, engineering is often one of the kind of biggest costs associated with a project. So if you're looking at kind of improving the performance of kind of a container by kind of 5–10%, if you spend a lot of time on that, it actually takes a long time for that amount of effort to actually reduce kind of cost savings in the long run. As long as your application is kind of performant, you generally don't need to worry kind of like too much about kind of optimizing it to the kind of nth degree. So, we've all probably had kind of those engineers who kind of sit in the corner, they put their headphones on, they work away, and you find out that they've spent kind of like 3 weeks kind of absolutely optimizing something so the SSL kind of negotiation is just a tiny bit quicker. And you think, in the grand scheme of things, it's not going to make that much difference. So there's a handy kind of sign we can borrow from the construction industry on that. So we're tending to take that approach. It also doubles up as a dress code, which is quite handy. But going back to the kind of tools that we're talking about as well, Hjelm is a tool that we introduced onto a project recently. And this kind of is one of the things where we had quite a lot of discussions about that. We had discussions with the client and they went through the kind of approval process for that. And the reason we went for that, there's a few reasons, but obviously Hjelm kind of improves shareability and code reuse across teams. So it's the kind of thing where once someone has written a set of a service, an application, we can share those across the teams. We don't have to kind of reinvent that all the time. But the other side of that as well is it actually makes that kind of pipeline easier to work with. So we can say to the teams, basically, you can do your development however you want. You can do your branching strategy, your actual kind of the construction of your artifact, however you want to put them together. But then you give us a Hjelm chart, and we can then deploy that through the environment. And we took kind of like that approach with Hjelm. That's kind of worked quite well. We're having kind of quite good results with that. And our test team's also taken a similar approach with Serenity. So that is a test framework that they've actually kind of built all of their tests into. So they've kind of put in their kind of Cucumber stuff and their JMeter, Selenium. And they kind of built that all into one framework that's shared across the teams. And we go on top of that, and that's then built into a Helm chart, which again, then we can deploy down our pipeline. So the thing here is kind of like really kind of cutting down the kind of like amount of reuse. So we've taken this from kind of like the high level, looking at kind of the application and service level with kind of Helm and Serenity. But we're also starting to look, and we're kind of doing quite a bit of work on this, so taking this down to a lower level. So taking this actually down to the design of pods as well. So pods are the smallest unit in Kubernetes. And they are containers that run on the same logical host. They share the same IP, same port space. And I think a lot of people, when they first start with Kubernetes, they take the view that, kind of a pod equals a container approach normally. But we have, because we want to take that same approach, we're looking at kind of splitting down the pods and kind of separating out functions that often are kind of built into the application containers themselves. So, we want to actually take what's kind of can be an application that does a lot of different things and break out those different things as much as possible. Even things that normally you'd think is just kind of like a function of the service itself. And to do that, we use kind of Sidecar containers. So this is a Microsoft definition of kind of Sidecar containers, and that's pretty concise. It's named Sidecar after the idea of a motorcycle and sidecar. That this is something that attaches to the kind of like main application itself. It runs along with it, and it doesn't split off. It's just doesn't do the whole Wallace and Gromit thing. It's actually it lives with the pod. So these different to init containers. I think a lot of people have used init containers before. So they're things that kind of start up. They kind of initialize some of the state that you need in your cluster. So often we'll see people using those to kind of put some initial state into kind of a database or do some initial work that the pod needs. And Sidecar containers within a pod can share information in a number of ways. So they can do files, they can do system phase semaphores, they can do POSIX shared memory. The other thing they can do is communicate over localhost as well. So any container within a pod can speak to another container over localhost. So the localhost method and Kubernetes volumes are the simplest ways to deal with this. And again, we're kind of taking a pragmatic approach here. So we're not looking for kind of necessarily the quickest way to do this, but the file system and localhost are pretty decent ways of dealing with it. Obviously, going over localhost does add a little bit of latency, so this may not be suitable for every kind of system, but it is quite small. So in the grand scheme of things, if you actually work out exactly how much kind of like how much time this is adding, it's normally quite small. So this is kind of the standard kind of application that we've got a couple of teams using, kind of almost like legacy Kubernetes applications, which is a bit of a weird thought, but we actually do have some that have kind of been around for a little while. And often you'll get something like you'll get a kind of Tomcat container running, and it'll need to talk to kind of a lot of external services. So it'll need to talk to other pods within the cluster. It might need to talk to completely external services from the cluster into kind of other networks. And there'll be things that it needs to kind of negotiate with. So it might have like something like an OpenID system, something kind of like Red Hat SSO or Keycloak. And each of these things will have different requirements to how it kind of talks to that. So this kind of setup can cause a few problems. First off, you're starting to kind of like add a certain amount of logic in there. So SSL is obviously one thing that's, people are relatively comfortable with setting up, but it does mean kind of you've got to build your certificates into your application, or you've got to inject them in somewhere where it starts up. So I know we've had a few teams, for instance, where they'll kind of pull in their certificates, they'll run update CA certificates when the pod's actually starting up to update those. Pulling in from Vault, again, that generally needs a little tool kind of built in there. So, something like console template, which will pull the key value pairs out of Vault, and it'll write any secrets that the pod needs. And also even kind of little things like, when you're putting your kind of Tomcat image together, you might need to go get a JSON kind of policy, jurisdiction policy files if you need certain types of encryption available. So it does cause kind of like a few little problems. But what we started doing was splitting some of these functions out. So the first approach we take with that is to put in an nginx sidecar. So this is kind of quite a common pattern. This is putting effectively an nginx reverse proxy within the pod. This handles kind of all incoming traffic, so anything coming in externally from the internet or anything coming in from any other pods. It does the SSL termination, which nginx is really quick at. And it can also host some static content as well, so you can take a little bit of load off your application pod. This just then forwards it over localhost to the application itself. You can go a step further than this as well, which we've done kind of quite a few times. And you can also start using that to deal with outgoing traffic. So this is something that's quite useful because now your application just has to talk over HTTP to kind of a localhost address whenever it wants to talk to anything else. You can deal with SL inside nginx, but you can also do stuff, start layering on things like basic auth between your pods quite easily without having to kind of change your application itself. Nginx can handle the basic auth between pods, for instance, on that front. There's also, excuse me, there's also a security advantage to this, that you can start locking down what your application can talk to based on the fact that it has to go through nginx. So if you, for instance, if you edit nsswitch.conf within the application container, you can tell it not to kind of look up anything over DNS. So it will be able to access things on localhost. So it'll be able to talk to nginx, and you can kind of have set defined paths that get forwarded onto other pods. So you can effectively start putting within your kind of pod structure a list of other places that the pod's allowed to talk to. So that really starts kind of giving you a bit of extra control at the actual pod level, let alone at kind of network policy level about what your pod can talk to. We've done that kind of with other services as well. So we frequently put in things for doing mutual authentication with kind of other services. We often split that out into another nginx container as well. Technically, we could build it into the same one, but we have a number of services that are running that different teams need to speak to. And it's quite easy if you do that. If you have the deployment configuration for nginx set up for that particular service, it's then really easy to move that between teams and say, okay, if you want to talk to this external service, just drop this into your configuration, go, and you don't have to worry about kind of setting that up yourself. Sometimes it does get a little bit interesting, and this isn't the nicest kind of setup, but we have kind of, on occasions when we've needed to go through kind of various proxies that we've not had control of, we've even used things like SOCAT within Sidecar container to kind of just help forward through, because nginx isn't brilliant at kind of this kind of forward proxying. We could have put something in like Apache, which has kind of proxy remote. We could have put Squid in as well, but again, we're trying to kind of limit the number of tools we're bringing in here. We generally have kind of quite a lot of expertise with kind of nginx. It's something that a lot of people have worked with. So, we stick with that. We put SOCAT in front if we need to. And it's actually, it's something that's quite easy to get from a kind of conceptual level. And it saves us having kind of yet another tool that someone has to learn. So, I'll get up the Vault Sidekick in a minute. But what I will show you, and I can get this up, is the nginx container that we're using and some of the setup for this. So this is kind of an open resti based nginx. So this is from the home office, and this is on GitHub. It's open source, so you can have a kind of a look through here. It's a really kind of good container to use for this kind of thing. It's got it's open resti. It's got Lua scripting available in there as well, and the README is kind of fairly kind of like detailed, and it's got a lot of things that are dealt with environment variables. So these are kind of easy to set up within your kind of Kubernetes kind of deployment. They then lend themselves quite well to being shared across teams and for other teams to build them into their Helm charts. So we have an example of the kind of thing we get with nginx. I will kind of like share these out as well so you can see afterwards. But this is the kind of thing that we can kind of like quite easily build into kind of a Helm chart. So we kind of like, we can put the definition here and we can put in kind of how we set up the different proxies that we need to speak to. So we have things kind of like this location CSV environment variable that we can kind of pass some paths to, basically. So when the application wants to talk to one of these locations, it hits one of these paths. And then the actual environment variables for those paths are actually set up kind of like simply with kind of like some numbers on the end. So it's kind of quite a kind of clear and concise way of kind of getting nginx set up. It's a little bit different to just loading kind of like an nginx conf file and the locations files and stuff. But the advantage of this is it's quite easy to just have kind of inline in your chart. And it's kind of like quite nicely readable. You can kind of open this up, you can see what your locations map to and what settings you're putting on there. So we can have different settings per location. We can put basic auth on it. So we've got things like kind of an initial reverse proxy to the application set up there. And then we can do kind of an internal service, which goes to a service.cluster.local address. And then we can do an external service as well. And we can start adding things on. You can add on kind of arbitrary location config as well. So in that instance, we're putting on some basic auth. So this isn't parameterized out, this kind of example there, but it's quite easy to then kind of turn this into kind of something that is more kind of Hjelm specific, and you can start parameterizing the variables out. You can also start quite easily putting kind of conditionals in here as well. So it's something that's easy to share. You know, we can start putting things like, you know, if you've got kind of like a stubbed environment, you change the locations. And because they're environment variables, you can actually just change that up here, and it'll just ignore the environment variables that aren't used. So that's kind of nginx proxy that we're using. It's kind of open source, and it's worth a look because it's got some quite neat features. So the next thing we are adding in at the moment is Vault Sidekick. So this is kind of like, this is where I think the kind of like power of this kind of approach really starts to kind of shine, because you can start kind of linking these sidecars containers together, and they kind of start getting kind of more powerful the more you kind of like get them to kind of talk to each other. So Vault Sidekick, again, that's a home office container that's available on GitHub as well. Again, that's open source. What that does is that speaks to Vault, which is our secure key value store, and that pulls down things like secrets. So if the application needs secrets, it will pull them down. And in this instance, what we're doing is we're writing them to a mount secrets volume. When we set that up, we tend to use kind of the memory type when we're setting up the Kubernetes volume type. So it's kind of ephemeral. It's just held in kind of memory on the node. But it can be shared across all the pods here. So we can write those secrets into Tomcat. And at the same time, we can put secrets in nginx for things like basic authentication. Where this actually then has an extra feature is if we add the PKI backend to Vault, it can dynamically generate certificates for services. So Vault Sidekick can request a certificate for a service when it spins up. And it can also renew those certificates, it can roll them over. And it can do that on kind of like quite, you know, whatever schedule you want. So these are things that can be rolled over every day. Even more quickly if you want. I know we've got one team who are rolling them over every 2 hours, but it means that, you know, the certificates are kind of like refreshed kind of regularly. And again, Vault Sidekicks pull those down, and it puts them in a volume, and they're shared with the nginx container. So the nginx container then has these new certificates on the file system. So because we're using nginx as well, one advantage nginx has over kind of trying to do this in Java is that it's really easy to do a reload of configuration with nginx. So we have had some teams before, so they've looked at, there's a Netflix library for Java called Arceus, or Arceus, not sure on the pronunciation, but that lets you do dynamic reconfiguration within Java. But then that doesn't help people who want to use a different tool, if they want to use kind of Node or React or something. So we can write the certificates into the file system with nginx, and then we actually can hit an endpoint. So this is, we can write a little bit of Lua scripting that when we hit an endpoint, nginx does a reload, and they're zero downtime. So nginx will stop the old process accepting new connections, and it will bring up a new process with a new config. So it's kind of a really nice way of kind of making sure that, you know, you've got a way to kind of change config quickly without having to kind of put extra libraries in your application, without having to kind of like should do any kind of hard restarts or bring up new pods with the new configuration in. So for instance, this is where the kind of advantage of this approach starts coming in. So we can swap out the application we've got for a different type, but we can also swap out the Sidecar containers and the actual infrastructure surrounding that as well. So if you wanted to swap out Vault for something like CFSL, You can put CFSL in as your infrastructure. That becomes your new kind of like tool for creating certificates dynamically. And again, the Home Office has a tool called CFSL, Sidekick. That again, that's on GitHub. You can have a look at that as well. And that does the same thing. But it just shows the kind of the flexibility you've got with this arrangement. You're not kind of tied to a particular tool, and you can move these around quite freely. So what this has allowed us to do is move to kind of short-lived dynamic certificates with zero downtime config changes. Nothing's baked into the containers. So this is, we have had people, they were baking kind of like long-lived wildcard certificates into containers, and that's obviously not brilliant. And the entire SL configuration is service agnostic. So we can share this from a team writing a kind of web front end to a team writing a back end. And they don't have to do any changes. They just plug their application into the middle. All it has to do is basically be able to read from a mounted volume and be able to communicate over HTTP. So that makes it kind of easy to implement. What it also does is it makes it a little bit easier to move to things like rootless containers. So that's something we've been kind of like working for a while on. So, we've got some historic ones that we've been moving over, but some of the ways that the kind of more monolithic containers were done, they were quite difficult to move across because they'd be running tools that kind of needed root access. So this has made it a little bit easier because each kind of container is back to kind of running effectively one process. It doesn't have these supporting things like kind of update CS certificates or console template to be brought in as well. So that's helped on that front. And this OIDC proxy, this is a new proxy that we're just kind of doing a proof of concept on now. But this has actually come about because we actually had problems setting up our kind of like our OpenAuth setup. It's one of those situations where one team had it working with their Java application, another team were really struggling to get that working with their kind of Node application, and kind of spent a lot of time looking at this. And it's, OpenID can be quite complicated when you've got kind of interesting kind of network setups and when you kind of lock things down securely. But that is available, that proxy is available as a container. This isn't from the Home Office, so this is from Smartzone. But this is OpenID certified. This is a Lua resti OpenIDC proxy. And this actually lets us kind of encapsulate that OpenID auth and kind of move that out of the actual application itself. So this handles all of that. It will kind of like do the negotiation, and then it will kind of pass JWT tokens around. So, this is kind of something that's been quite interesting. We're actually already seeing that where this could have saved us kind of a lot of time recently. That if we had one team who had already set this up, the other team could have just taken it, even though they're running a different service, they could have taken it, moved it into their pod, and they would have had to make minimal changes to actually work with it. Whereas as it was, we were having to bring people across. And the other problem you have when you have these pods that are designed kind of individually by the teams is some of your troubleshooting becomes more difficult. So, we moved people across who knew how OpenID worked, how it was all kind of set up, but they weren't aware of how the team itself had kind of set up their kind of application, how they'd put everything together. So then you're automatically building in kind of an acclimatization process where people troubleshooting it from other teams who can help are having to spend kind of half a day getting to grips with what the other team have done. Whereas if we can kind of abstract that away, it makes it a lot easier. So the other thing we're putting into kind of pods at the moment, things like kind of monitoring and kind of logging containers. So FileBeat's one that we put in occasionally. It's not my kind of preferred way for dealing with FileBeat in most scenarios. So normally kind of, I suggest if possible, that's kind of a daemon set that just kind of picks it up from the actual node itself. That's not always possible in kind of, in certain projects, depending on how the kind of cluster's managed. So it may be that the cluster is shared across kind of like quite a lot of teams. You may not have control of the cluster. So quite a few projects we work on, there is a bit of separation between who runs the actual infrastructure and the delivery teams. And there can be security reasons for doing that as well. So if you have a secure application where you potentially could log something that was kind of personally identifiable, you wouldn't necessarily want that going into kind of like a standard log. It would need to go into a secure log where things were locked down. So by putting a FileBeat container in there, it enables you to actually kind of control where that's going. And you can do that by exception as well. So you can have a daemon set that does handle kind of generic logging. So you can say to the teams, look, if you want to log to the kind of filebeat daemon set, that's absolutely fine. You just, you point your logs to standard out and they'll get hoovered up and they'll get passed along to elk. If you need to do something different, whether that's for security reasons or you need a different type of logging, so some teams may want to use FluentD or something else for whatever reasons, they can actually just build that in as a sidecar. They then mount that volume inside the application, so something in this case like mount logs. And then they tell their application to write their logs kind of into mount logs. We'll hoover that up from there. So there's a few different tools you can treat like that. There's things like Jaeger for tracing as well. I've mentioned FluentD before, but even if someone wants to kind of like run a multiple set of these for reasons and actually split their logs onto different systems, again, it just gives you that ability to do that. And in the end, this is kind of like about giving the delivery teams the choice to kind of like how they want to put things together, but not having to reinvent it each time. So, we've had kind of quite a lot of success doing it, and it's definitely kind of like reduced our actual kind of like, time to life for teams that have started to kind of like take this approach to it. And it's also made those kind of troubleshooting steps easier. So I've got a kind of conclusion from a software engineer at Google, Brendan Burns. So his view on this is it can, speed application development. You codify that expert knowledge, and that's a big thing because, with these large kind of rainbow teams, you do have people that, you'll have experts in nginx, you'll have people who really kind of understand SSL. Making it like this, you can use that expert knowledge without them having to learn how different teams have done things, and it really makes a big difference. And it does enable agile teams as well because you can kind of take that small parcel of work, you can give that to a team and kind of pass that on them for them to do. Okay. So there's a few links there. So there are kind of the 3 sidecars kind of I mentioned there specifically, and they're worth having a look at. And my email address there if anyone's interested in a DevOps role. We are kind of continually looking for good engineers. So that's great. Thank you very much.